For exercise 5, the average pH of normal arterial blood is 7.4. At normal body temperature 37 kW, 2.4 exponent negative 14. Calculate H plus and OH minus concentration for blood at this temperature. Okay, first of all, you look at this value for kW here. This is 2.4, right? So, dia berbeza dengan kW yang kita belajar sebelum ini, iaitu kW equals to 1 exponent negative 14. Okay, ingat, this water constant is referred to the temperature 25 degrees. So, kalau temperature berubah, kW pun berubah. Okay. Soalan tanya concentration H plus and OH minus. Okay, first of all, you kena tanya diri kamu dulu, perlu tak saya nak buat ice table? Jawapan dia tak perlu. Okay, no need. Because sebab kita tak merujuk kepada weak acid ataupun weak base. Kita merujuk kepada blood at this temperature, blood di dalam badan kita. Okay, so bila tak merujuk pada acid ataupun base, weak acid ataupun weak base, tak perlulah nak buat ice table. Dan lagi satu, one more thing, ice table just to find the value of Ka or Kb, then the equilibrium concentration, final concentration. Okay, for this case kita bukan nak cari final concentration, nak cari H plus dan OH minus here. Okay, di sini dia ada bagi data tentang kW. So you remember balik apa formula yang melibatkan kW. Yang pertama, kW equals to Ka multiplied by Kb, and another kW is concentration H plus multiply concentration OH minus. So for this case, sesuai tak kita nak guna the first formula? Tak sesuai, not suitable, because this value Ka and Kv did not given to us. Okay, so not suitable. The only suitable here is formula. So you have to starting with the formula. Sorry. Okay, become kW. For this case, kW already given 2.4 exponent negative 14. Okay, but what's the value for concentration H plus dan OH minus? So di sini you tak boleh assume ini X, because ini bukan normal temperature pada 25 degrees. Bolehlah kita assume sebagai X dan X. For this, ini adalah blood, okay, arterial blood kita. So, apa yang perlu kamu buat? You kena cari concentration H plus. Kenapa saya kata kena cari? Because pH is given. Kalau pH given, kita tahu pH equals to negative log concentration H plus. So, pH for this arterial blood is 7.4. So from this, you will know the concentration for H plus. Okay. After you get this, baru you masukkan dalam this formula. Okay, kata di sini you akan dapat concentration H plus nya adalah 3.98 exponent negative 8 molar. Then 3.98 exponent negative 8 multiplied by concentration OH minus equals to 2.4 exponent negative 14 diberi di dalam soalan. So you settle down and you get the concentration OH minus, which is 6.03 exponent negative 7 molar. Don't forget your unit. This is your answer. Alright? Okay. We move to the next question. Exercise C. Exercise 6. 0.2 molar solution of weak acid is 9.4 dissociated. Already stated this is weak acid HX. X, this is unknown lah. Okay, 9.4 dissociated. That means dissociate 9.4%. This is your percentage dissociation. Using this information, calculate H3O plus, X minus and HX concentrations at equilibrium. Determine also pH and Ka for HX acid. Okay, already give you the final answer. Okay, kalau kita baca soalan, dia tanya concentration at equilibrium and Ka. That means perlu tak ice stable? Yes, confirm ice stable needed. Why? Because yang pertama dia merujuk kepada weak acid stated here. Dan yang kedua bertepatan dengan function ice stable, iaitu nak cari Ka or Kb. For this case kita nak cari Ka, and the function yang kedua kita boleh cari concentration pada equilibrium. Yes, concentration at equilibrium. So ice stable needed. Okay. So di sini kita akan buat starting dengan dissociation equation. Dissociate in water to produce, okay, this is weak acid, which is proton donor. So become X minus, this is proton acceptor. Alright, so become H3O plus. So all subspecies is aqueous, okay, except your H2O. Okay, this initial change and equilibrium. This is your unit. Okay. Initial concentration, this 0.2 not included, 0 and 0 here, minus X plus X plus X, 0.2 minus X, X and X. Normally di sini Stokio dissociation equation adalah 1. Okay, sebab kita melibatkan monoprotic here, 1H sahaja. Okay. Terus K expression, so concentration X minus over H2O plus over HX. Okay, and then you masukkan value Ka. Kita nak cari Ka, so kita akan masuk macam ni. Betul? Alright. Perlu tak kita checking? Tak perlu. For this case, soalan ini no need to checking. To check 5%. Why? Because, okay, why? Because Ka not given. Okay? So kalau you nak check 5%, kalau Ka or Kb given, yes, boleh check. Kalau tak bagi Ka, tak bagi Kb, that means no need to check. Alright? So for this case, you cannot settle down this value of Ka because you don't know what the value for X here. Okay? So what should I do? Okay, refer to the next data, which is saya already highlight di sini, iaitu percentage dissociation. So from here, okay, next step, percentage dissociation is 9.4%. Okay, next. Just substitute. Okay, sorry, percentage dissociation. Then you masukkan formula dia, iaitu X over initial concentration multiply by 100. equals to 9.4. Okay, so X you want to find. Initial concentration for this is 0.20 multiplied by 100 equals to 9.4. So your X, you settle down, you will get 0.0188. Next, after you get the constant, the value of X, bermaksud X ini merujuk kepada this concentration, X ini merujuk kepada this concentration, and you get the value of concentration for Hx, okay, at equilibrium. So next step, X equals to concentration X minus equals to concentration H3O plus equals to 0.0188 molar. Accepted because you telah combine menjadi sekali di sini. Saya terima. Okay. Bila dah dapat yang ni, nah yang ini, now nak cari concentration Hx, okay, pada equilibrium kita tambahkan. Now Hx, concentration Hx equilibrium, 0.2 minus X equal to 0.2 minus 0.0188 equals to 0.1812 molar. Okay, next kita cari Hx, nak cari pH. How you get the pH? pH equals to negative log concentration H3O plus. Why I write H3O plus? Because your dissociation equation, you write H3O plus. Negative log 0.0188 1.73. This is your answer. Okay, how about Ka? Okay, Ka equals to X 0.2 minus X, that means 0.0188 squared over 0.0188. Sorry. Okay. 0.2 minus 0.0188. And you get the value 1.95 exponent negative 3. So this is all the answer needed in the questions. Okay, we go to the last question, which is exercise 7. Calculate the formed ion concentration and pH of solution that is 0.05 molar in formic acid. Given Ka for formic acid is 1.8 exponent negative 4. Alright, calculate formed ion. Ion, that means sebagai dia punya produk lah. Okay, pH of solution. So soalan dia yang pertama cari yang dulu, yang kedua baru pH. So perlu ice stable? Yes. Formic acid is organic acid. Organic acid is weak acid. You needed ice stable because you want to find the concentration at equilibrium. Okay, concentration here. So dissociation constant dulu, dissociation equation dahulu. HCHO2 dissociate in water, right, become CHO2 minus and H3O plus aqueous, liquid, aqueous and aqueous. Kalau yang dulu macam ni pun tak apa. Okay, HCOOH. Ini pun formic acid. Okay. Saya tunjuk dua-dua. Okay. Dia akan jadi CHCOO minus equals plus H3O plus. Maybe you lebih familiar lah dengan formic acid with this molecular formula. Okay, lebih familiar. Right? Okay. Initial change equilibrium. Right. For unit, initial concentration is 0.05 here. Liquid not included. Alright. Negative X plus X plus X. Okay, make sure here you tulis dengan betul Okay. 0.5 minus X, X and X. Right, your Ka expression. Kenapa Ka? Sebab dia adalah acid. So H COO minus H3O plus over HCOOH. Okay. So this is the value 1.8 exponent negative 4 equals to X over 0.05 minus X. As usual, before you expand AX squared BX plus C equal to 0, you must checking 5%. Okay, A equals to Ka over initial square root times 100 Ka 1.8 exponent negative 4 over 0.05 square root 100, and you will get the value which is 6%. This value is greater than 5%. So what you should do next, Ka very large than 1. So X, okay, X are not negligible. So you write again the expression with the exact value, but this time 0.05 minus X, you have to expand, become quadratic. Take exponent negative 4 minus 9 exponent negative 6 equals to 0. You tekan calculator, you will get the answer for X1 and X2 negative 3.09 exponent negative 3. As usual, common sense, always your value of X is positive. So X equals to concentration form an ion, which is 2.911 exponent negative 3, include the unit. Okay, pH. Okay, X equals to concentration H3O plus 2.911 exponent negative 3, pH equals to negative log concentration H3O plus. Normally tulis formula kena tulis formula all the time. You get the value is 2.54. This is your answer. Okay, the first one molarity form ion, and the second one is pH of the formic acid.